What's going on, everyone? This is Kevin with Noble IT, bringing you another video. Today we're going to be talking about traditional site-to-site VPNs, and specifically the crypto map on a physical interface. You can do this on a logical interface, such as a tunnel interface, but we're going to talk about the crypto map on the physical interface. So yeah, this is Noble configurations, and I'll drop some knowledge around the way, and I'll show you how to configure it, and then also how to verify that your traffic is being encrypted. So yeah, let's get to it. Here we have, you can see, we have our topology-wise, we have our HQ router over here. We have our site B router over here, and it traverses an MPLS core over here. So we're just going to use this as our ISP. So our gateway is going to be provider edge 1 for HQ, and our gateway is going to be vice versa, provider edge 2 for site B. So I'm going to establish a nice little site-to-site VPN from this router to this router, and my goal is to have this loopback network 1.1.1.1 successfully talk to 2.2.2 over here and make sure that the traffic is encrypted. Now that's going to simulate, you would have your private LAN over here talk to this private LAN over here encrypted. All right, well, let's get to it. Let's go ahead and open our router. So let's, I'll go ahead and give you an overview of the interfaces. This is what we have currently, loopback 0. You don't have to worry about that tunnel. We're not using it. So yeah, all we care about is loopback 0 and then our physical interface. So task number 1 is create ISACAMP policy for IQ1 phase 1. So let's go ahead and do that. So create ISACAMP policy. We're going to do config T crypto ISACAMP policy. We'll just name this policy 1. Here you get to define what's in this policy. So if you do a quick question mark, you can see that you have multiple commands that you can do: authentication, encryption, group hash. So we'll go ahead and keep this similar. So we'll do encryption AES 120. Actually, we'll just do encryption AES. We'll do authentication. It's going to be pre-shared keys. Group is going to be 14, Diffie-Hellman 14. And hash, we're just going to do SHA-256. And lifetime, I'm pretty sure the default is A6400, but let's go ahead and specify that. So that's good. That's configured. That takes care of the ISACAMP policy for IQ1 phase 1. Now we're going to create the phase 2 policy in transform set. Oh, hold on. I think I actually forgot to add a task here. I sure did. But it's all right. It's on the fly here. We'll just go ahead and 1.5 task right there. It's going to be to create the ISACAMP key. We can't forget that. So let's go ahead and create the ISACAMP key before we form anything else. So we're going to do crypto ISACAMP key, and this is all going to be one line here. Crypto ISACAMP key. We'll do a password of Cisco 123. If you see here, you can do a host name or IP address. We'll do address. Now this is going to be the physical IP address. So I'm on HQ router. So the physical IP address of this router, which is going to be 40.50.60.5. So we're going to do 40.50.60.5. And looks like I already have a pre-shared key for that address. So it looks like I forgot to delete it. But yeah, crypto ISACAMP key address 40.50.60.5. So that's configured. Now that takes care of that task. And then task number 2, create the phase 2 policy and transform set. Okay, so we're going to do crypto IPsec transform set. What are we going to name this? We're just going to name it tset. And then it gives you many options on what you want to use here. You can use encapsulation security protocol with authentication header. And you want to kind of use a combination of both to provide, data integrity and encryption. So we'll go ahead and do ESP AES, and then I like to use 128, and then I like to use authentication header SHA-256, and that'll be it for that. And by default, if you do a question mark, by default, the mode is going to be on tunnel. So you can either choose one of those two, but for this configuration, there's going to be tunnel. So that is going to take care of the transform set here. Now we're going to create the crypto map to define certain properties in there. And I'll show you what those are. So to create the crypto map, you just type in crypto map, name it whatever you want to. I'm going to name it crypto map. And then here you get to specify the sequence number. So I'll just do a sequence of 10. We're going to select IPsec ISACAMP. Okay. Now note that the crypto map says will remain disabled until a peer and a valid access list have been configured. So it tells you that this is not going to work until you specify a peer and a valid access list. So let's go ahead and clear the screen. You can see it gives you the commands to do so. So in order to set the transform set, we're going to do set transform set, and then this is going to be the transform set name that we created. So that takes care of that. Now, what else did it say? We need to set the peer. So the peer is also going to be the physical IP address, what we specified earlier. So set peer is going to be 40.50.60.5. Okay, so that peer is set, and then we're also going to match an address. This is going to be an ACL. We haven't created this yet, but it'll still work. We're just going to name it match address 100. Okay, so that takes care of the crypto map. So if we do a show crypto map, you can see here that the crypto map that we created gives us a warning. The crypto map is in an incomplete state. And that's not because we didn't specify the ACL or missing peer. It has the peer, it has the ACL configured, but we just haven't created the ACL yet. So we're going to do IP access list extended 100. And this is where sometimes crypto maps can be tricky, right? So we're going to permit, basically want to match all the traffic from this site that needs to be encrypted to talk to this site, right? And so you can see there you have to be very granular, and it could be tedious if you have a lot of networks that you need to talk to other networks. So here for this example, we're going to specify the loopback network 1.1.1 to talk to 2.2.2. Okay, so we're going to permit IP 1.1.1.1 wildcard bits, and we're going to have this talk to 2.2.2.2 wildcard bits. So yeah, that's a very simple permit statement. Obviously, if you have a couple networks, it'll be a little bit more lengthy. So that'll take care of our access list. So now if we do it, do show crypto map, you can see here that we have no errors. Our crypto map is configured correctly. You can see here the access list showing. So now that we have the crypto map created and set, we're not going to apply it to the interface just yet. I want to configure an IP route, basically a default route from this HQ router to my gateway. So my gateway is 40.50.60.2. Okay, so we're going to create an IP route, a default route, 0.0.0.0 to network or subnet mask 0.0.0 to the next hop 40.50.2. Right, so this is going to send all my traffic to 40.50.60.2, okay, which is what we want. So now we look at the tasks here. We created the crypto map, created an ACL, created a default route to the gateway. Now we have to apply the crypto map to the interface. So now we can go into interface Ethernet 0.0 and simple as crypto map and then the crypto name that you configured as crypto map. There we go. We can see we got a little log that says ISACamp is on. So let's do a quick show run on the crypto configuration. So this is what we have got going on. ISACamp key of Cisco 123. This has to match with your peer. The key has to be the same or it will not negotiate. We have the these policies also have to be the same. The parameters, policy number does not have to match. Crypto map, set peer, that's correct, that matches. Transform set is created. The transform set is there, so it is applied. So that takes care of this router. Let's go to site B and do a mirror configuration here. And we're going to go ahead and speed this through because we kind of know what we need. And I'm going to leave this up just so I know that it matches. So let's do a crypto ISACamp policy 1. Encryption is going to be AES. Hash is going to be SHA-256. Authentication is going to be pre-shared. Group is going to be 14. That takes care of that. And you can see on my configuration here, I specifically put lifetime, but that's the default, the one that I configured. So that takes care of the policy. We're going to do crypto ISACamp key 0. This will be Cisco 123 address. This is going to be that physical interface of 40.50.60.1. I've already created that on my previous video, so that's there. Now we're going to configure the transform set, crypto IPsec transform set tset. And just to make sure we're matching what we have on the other side, ESPAES mode. So I'm not going to specify the mode here. I could, but just wanted to show you that the default is tunnel. So that's complete. Now we're going to create the crypto map. We're also going to name it crypto map 10 IPsec ISACamp. Gives you that warning, make sure you do everything else. We're going to do set peer, which is going to be 40.50.60.1, which is that physical IP address again of your HQ router over here. You can see .1 right there. Set transform set tset, what we created, match address 100 of the access list that we haven't created yet, but we will. That takes care of that. And just to make sure, yep, warning, there's an access list there, but nothing in there. So we're going to create an access list, IP access list extended to 100, permit IP. Now here, we're going to do the mirror configuration. Basically, we're going to make sure that this 2.2.2.2 network can speak to the 1.1.1 network over here, that it's encrypted. So we're basically matching it so that way it's encrypted. It's not really blocking. It's just going to say, hey, this is going to be encrypted. So permit IP 2.2.2 to 1.1.1. It takes care of that. Simple as that. Now we can do a show crypto map, and there we go. Crypto map is good. Now we're going to in our interface Ethernet 00. This guy right here, our physical interface. Crypto map, and we get log. IceCamp is on. So let's look at everything else. We took care of those tasks. Create policy. Policy 1, we created the IceCamp key, which was the key of Cisco 123. Created the phase 2 policy and transform set. We created the crypto map, defined the peer, the transform set, and the ACL. Created the ACL to match network traffic to encrypt. Oh, I did not do the default route to the gateway on this one. So IP route. Let's see, that's why you always check your tasks there. Now this one's going to be 40.50.60.6. So this is a default route to my gateway right here, which is 40.50.60.6. So that's, and then apply the crypto map, which I've done. Now let's verify, right? So how do we verify that our traffic right here? So let's take a look at our topology. I want to verify that the 2.2.2.2 network is going through my interface and coming and hitting 1.1.1, and that the traffic is encrypted. How do I do that? We can do a quick show command for that. So we'll start on site B. The command is show crypto IPsec security association. Now what does this do, right? You see it's on interface Ethernet 00. Shows that it has a crypto map. Local address is .5, which is correct. Now you can see the peer, which is going to 60.1. Now here's the information that we really want, or that we really care about. Packets encapsulated, packets encrypted, packets decrypted, right? So with that being said, let's just do a ping to 1.1.1.1, right? So we're going to ping the HQ site, okay? Boom, we can hit it. Now, what do you think is going to happen? Do you think, so these are going to increment, is it going to stay the same? Is it going to go up? Who knows? Let's do that same command again, show crypto IPsec SA, and our traffic was not encrypted. Now, the reason why it wasn't encrypted is because when we hit that ping command, naturally it's going to come from the 40.50.60.5 IP address, right? We didn't specify in the ACL this network to be encrypted. So we only said permit 2.2.2 to 1.1.1. So if we modify this ping command to ping 1.1 and we source it from 2.2.2, we're forcing the pin to come from 2.2 to 1.1. So let's do that. Lose one packet to ARP. Now what's going to happen? There we go. We got 4 packets encapsulated, 4 decapsulated, 4 encrypted, 4 decrypted. Now we got only 4 because we lost one to ARP. So if we do that ping command again, we should get a total of 5 packets sent. So now it should show 9 packets. There we go. And it'll be vice versa, same thing. But yeah, that's a quick and easy way to do the site-to-site VPN with a crypto map on the physical interface. So I hope this helps someone or learns. If you got any comments, put them in the comment section. And thanks for watching.